Okay, to verify this trig identity, what I need to do when I'm verifying a trig identity is only work on one side of the equation. That's what makes an identity, not an equation. So what I decided to do is work on the left-hand side, and then I really wanted to get these to have common denominators, but then I got to fooling around one way and I didn't get any progress. So then I decided, well, if I multiply the 1 plus sine x by its conjugate, then I got to do that by the top and the bottom of the same value, because I don't want to change the value of the equation. I want to keep it 1, because that's just another form of 1. Whoops, that gave me this expression, and if you FOIL that difference of two squares, that gives you the 1 minus sine squared x. And then I remembered the identity, sine x squared plus cosine x squared equals 1, and if I solve that for 1 minus, if I move the sine x squared over to the other side, I get that value, so I can replace this with a cosine squared, which I did. And then I noticed I've got a cosine x over cosine squared x, which meant I could think of cosine squared x as cosine x, and cosine x cancel out one of those cosine x's. Now I've got two fractions with the same denominator. I can just combine them by adding the numerators. And I've got a negative sine x and a positive sine x, which cancel out to 2 over cosine. And we know that 1 over cosine is the same as the secant. So that expression becomes 2 secant x, which is, if I look back at my original equation, that's what the right-hand side was. So I just verified that trig identity.